Let's do it. Five. Whoa. Side's not representing today, right? Yeah, that's. Do people sit over here because this is the side I lecture to, or the better students sit over here?
They're blind followers. We have free will.
Yeah, free will. Yeah. All right, let's do it. Real snow out there. Sick. Maybe we'll have a real winter this year. I hope so. In the spring, I only teach classes on Monday, Wednesday, Friday at 2 o'clock and 3 o'clock on purpose so that I can only ski in the mornings on Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. So it's awesome. I've really made it in life now because I literally have set it up so that I only have class in the afternoon. So I go up a lot. All right. So let's do this, right? We're in the last stretch. We're doing 3D dynamics, right? By the way, I have not graded your exams, but again, I'll have them back to you by Wednesday. Probably tomorrow evening, I'll post the grades. So far, they're looking okay. Okay, I kind of flipped through them, and there I saw some right answers in there. Last time there was only like I don't know if I mentioned this. That one of the problems last week only had like 3 right answers in the whole thing. So I was impressed. So far, I've seen at least like maybe 20 right answers on a couple of them. So, all right. So we're in the middle of this, right? Last stretch. This is the last thing. We have 3D dynamics. We're going to do 3D kinematics, the stuff we're dealing with right now. We've kind of already done it, just now we've added extra components to it, but the process is the same. You're not learning a new process. Then we're going to do 3D kinetics. F equals ma. Again, we've already learned the process. We've done it twice now for particles and then rigid bodies. Same thing's going to happen here. Just things get a little bit more complicated. By a little bit, I mean a lot of it. Okay, they get a little, but the process stays the same. Okay, the final exam will have 2 problems on it. Right, the problems will be 1 3D kinematics and 1 3D kinetics. But then there also is about a third of the test is going to be cumulative. Conceptual questions from the whole semester, right? So, yeah. Yeah, multiple choice, true, falses, right? Yep. So about a third of it. And typically, you guys do terrible at that. So, just like you do okay at the problems, but the conceptual stuff, I get you, okay? So that's the Wednesday. We have our final Wednesday of finals week. I think it's at 8 a.m., right? We're used to it now. We'll do it at 8 a.m. It's going to be over in Gaines. And we'll crank it out. Okay, so we were doing this, right? The thing that with 2D, velocity and acceleration were only 2 dimensions, right? X and Y direction. And omegas and alphas were only 1 direction, right? It was rotations about the Z axis, right? In our moment of inertia, the only one that mattered to us was IZ, okay? Now when we go into 3D though, all of these things are three directions, X, Y, and Z. We can have movement and acceleration and velocity in the X, Y, and Z direction. And now omega could be in the X, Y, and Z direction as well. That's where things get really nuts, is those things are in 3 different directions, right? And then we have moment of inertia, right? So our inertia becomes an inertia tensor, and there's 6 components to this, and it actually becomes a 3x3 matrix. There's symmetry in there, so that's why there's only 6 components. And we have this thing called moments of inertia, and also something called a product of inertia that's going to be floating around. So things get a little crazy. Our moment equations are going to blow up because of that. Okay, but if you do it in matrices, it actually isn't too bad. Okay, so then right, we're in kinematics, right? It's all about taking a point from one point to another point. It's all about geometry. Take a step from one point to another point and work our way around. Same exact equation that we used to do that for velocity that we did for 2D, right? Now, though, there's this concept of an object that can rotate about another object. And the way that I'm trying to handle that is by calling the thing that's rotating about the other thing that's rotating the body, and the thing that's being rotated by the other thing, calling it the secondary reference frame. Okay, so there's 2 different reference frames floating around. Okay, same equation for accelerations, but again, we've thrown in this concept of alpha of the body, and that's only when we have a thing that's rotating about a thing that's rotating. Okay, when we do that, this omega of the body, you basically just take the omega of the body as seen from the secondary, you add on the omega secondary. So you just add the two things together. But when we come down to accelerations, and we're talking about the angular acceleration of a body that's rotating about another thing that's rotating, we have these two accelerations. But if you have constant omegas, then these things are zero, right? And I think almost in every problem we do, those things end up going to zero. There is no, our omegas are always constant. But even if your omegas are constant, you still pick up an alpha, and it's this omega of the secondary crossed with omega as seen of the body as seen from the secondary. So you have this, and this is associated with something that's rotating, and you're changing the direction that is rotating, right? It's all associated with that. And when you do that, you pick up, it has to accelerate in a certain direction, and you have to make it accelerate, and you do so by applying a moment to it, right? So when you had that fidget spinner and you're spinning it around and you change the direction in which it's rotating, when you did that, you felt this it wanted to tip over, right? And so it's rotating this way, and I rotated it this way, but we had to apply a moment in this direction in order for it to accelerate that direction. If you didn't apply it that way, it would roll over, okay? That's back to my wheel. When I had my wheel rotating and I was hanging it from one axis and it was holding it there and it started processing around but not falling down, that's because of this, right? It's because of this omega crossed with omega term is why it wasn't falling down. It's really weird. It's a weird thing, okay? And you felt it, right? And I don't think you could do these problems with intuition, right? Like, would your intuition tell you which direction this omega crossed with omega is going? I don't think so, right? So some of you probably, you're smarter than I am, but I can't do it. I do have a feeling for why this happens. I got it, and I'll try to explain it to you at some point. Remember I told you think of these things as particles whipping around. I got it, kind of, okay? All right, so then that's the only thing. So we were right in the middle of an example, right? Just the drawing alone tells you how crazy this thing gets, but it's worth going over this again, just so we could just make sure this process is seeding. This one, maybe I've told you this before, but I had this former colleague of mine. He always messed it up, and he would never say beating a dead horse. He would always say beating a horse to death. And I'm like, that's a completely different picture when you do that. And so I try to use that as much as possible. So you might be like, oh my God, we're going over this again, but I'm trying to beat this horse to death so that you guys can understand it, okay? All right. Okay, so what we did, right, we do the same thing. We take a step from one point to another point, right, and then take a step from here out to here. Right? And so when I took a step from this point, I know that point's 0, or even down here at O is 0. Either place works. If I start out here as 0 and I take a step up to A, that one's pretty easy, right? That's just velocity A is omega of the secondary crossed with RA is seen from O. Same equation we used before. Now, though, I'm not on a thing that's rotating about a thing that's rotating. I'm only on one thing that's rotating, okay? I always think these lectures would be good for like high schoolers to come in and then like listen and be like, what the fuck is going on? Hopefully you guys are catching it, right? That since I'm only on the thing that's rotating and there's nothing, and I'm not rotating about something else, I just use omega 2 to make that step, right? Because I don't have to worry about the two things added together because I'm only on the one thing that's rotating. And then omega 2, again, you just gotta be really careful about which direction omega 2 is pointed, right? So if I take my fingers, rotate there, and I got my thumbs going down, so it's going in the negative Z direction. So you gotta be careful about your right hand rule and what's positive and negative. And so that's what I did at negative 12 in the K, crossed with 1.44 in the J plus 1.92 in the K. That's the stepping out to A right there. And then I get 17.28 in the I. So that says that this thing is going, this point right here is coming in the X direction right here, right? At 17.28. I buy that, right? My intuition would say that is in fact where it's going. Okay, then I'm going to take a step from A out to P. Well, now I'm on the thing that's rotating about a thing that's rotating. So I can't just use this omega. I can't just use omega 1, this omega 1 right here, because not only is that thing rotating, I'm also my baseline, this point A is also rotating. So I have to take and I add the two together. Right, that one's pretty straightforward. That one I get, right? I just take, well, clearly it's going to have both of these rotations and I add them together. The one thing that's a little bit interesting about this is that this omega has components associated with it, right? It's pointed up in the Z y plane, so it's pointed up in that direction. So I have to look at its different components. We do it just like our typical, break our vector up into two different components, and that's what we did, right? And so it has both of those components. And so here's my, so here I add the two omegas together. That's what we did right there, right? Omega 1 plus omega 2, right? And then omega 1 is this 20 sine of 36.9 and the cosine 36.9, right? It's both of those things. And then I just add them together, right? So my omega of that body, of this body right here is this line right here, PQ. The omega of that PQ is 12 in the J plus 4 in the K. That's the total omega of that thing, okay? So now once I have that omega, I can take a step from A out to P, and that's what I do. VP is equal to VA plus omega of this body, which I just found, plus, crossed with RP is seen from A. And then I just use the right omegas and stuff, and I take a step out there, and I find out that this point right here, right, is going 36 in the I. Right? And again, my intuition would say, yeah, it should be going in the I. It's rotating around that, and that point P is in the XY plane, the ZY plane, and so it should be coming out in that direction. Okay? So now I'm out there. Right, perfect. So I'm done with that one. That one's the velocities. Okay? Accelerations now. Right? So the way we do accelerations, right? Same deal. I start out here, I take a step to A, and then I take from A over to P. And so that's as far as we made it. We figured out what AA was, right? It was negative 207.36 in the J. And so AA has it's the centripetal acceleration that's accelerating back towards the middle, which again would pass our stink test. I think what it is this screen is closer than that screen. Right? Maybe that's what it is, because it's easier for me to look right there. But I have to walk way over here. I need to start doing it. I'm really uncomfortable over here. I don't like it over here. Okay. All right. So but then now I need to take a step. Now I'm on this body. Now I'm on PQ. And to go from A to P, I need to use the right alpha to do that. Right? The right alpha now is going to be alpha of this body. And that alpha, because now we're on a thing that's rotating about a thing that's rotating, right? Alpha of the body is alpha of the secondary plus alpha of the beta is seen from the secondary. Again, these things are constant omegas. Since they're constant omegas, these guys went away. And so what I'm left with is the omega secondary crossed with omega of the body is seen from the secondary. Okay? So now I got omega of the secondary. It was just negative 12 in the K. And the body is seen from the secondary is 12 in the J plus 16 in the K. It's not the total omega of the body. It's not this omega. It's not this omega. This is the omega of the overall body. It's this omega, right? It's just this omega 1 is all we use there. So it's omega of the secondary plus, or crossed with omega of the body is seen from the secondary. So I just do that, carry out that cross product, and I get negative 144 in the I, radius per second squared. So that's alpha of the body. Now I have that. Now I can take a step from A out to P. Okay, so that's what we're going to do. It's got to be crowded. Okay. AP is equal to AA plus alpha of the body. Now I'm on the thing that's rotated about the thing in the body, so I have to use that alpha body. Crossed with RP is seen from A plus omega of the body. Now I'm on that body, so now I need to use the full omega of the body, right? That's the two things added together. And I cross that with omega of the body crossed with RP is seen from A. Like, oh, that's not so bad, but then we actually substitute things in, and there's a lot of shit in here. AP is equal to AA was negative 207.36 in the J plus alpha of the body was 144 in the I crossed with the vector negative 1.44 in the J plus 1.08 in the K. Right? That's RP is seen from A right there. Plus omega of the body 12 in the J plus 4 in the K. That's just omega the body, and I cross that with the quantity of omega body again, 12 in the J plus 4 in the K. Cross that with RP is seen from A. 1.44 in the J plus 1.08 in the K. Okay, I'm sure you won't make any mistakes doing that. None, right? It'll just be nice and clean. I'll have all the same answers when we do this, right? But that's it. I mean, really, the hard part is setting that thing up, right? From here on out, it is just calculations, right? Just. I guess we call it linear algebra, just linear algebra from here on out, right? And carrying out cross products and stuff like that. If you learn how to do this with your calculator, beep, boop, 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 pretty easy, right? I think when you get into this realm, the realm we're going into, learning how to use your calculator and their matrices and stuff like that might be worth it, right? Some of the other problems, maybe not worth it because the cross products were easy and stuff. Now though, like look at all this, right? And so carrying this out with your calculator would be pretty nice, right? Or like in some of these homework problems, use MATLAB, right? Every once in a while, I get somebody that is brave enough to use MATLAB and they enjoy it, right? I give you some example code on the next page on how you would do this thing in MATLAB. Right? And I'll go through that briefly here in a second. And then if you carried this out, this is AP is going to be negative 288.2 in the J minus 432 in the K. And this is feet per second squared. All right. A good exercise to do would be to see if you can get that, right? I've laid out the equations for you, right? And see if you can get them. Pull out your calculator. Boop, 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 boop. Set up your matrices, right? Your little vectors. I guess these would be vectors and all these things, and just see if you can get to this, right? Or do it with the old right-hand rule. I don't care how you do it. Just depends on whether or not you want the right answer or not. If you want the wrong answer, do it by hand. If you want the right answer, use your calculator. Okay? What this would look like in MATLAB, right? This little code over here on the side. How many people have used MATLAB in the past? Almost all of you. How many of you hated MATLAB? Yeah, see, right? More people hated it than people that used it, which is a little odd, right? But I think the further you go on into school, especially if you go into grad school, you'll learn to love MATLAB. Me and MATLAB are best friends. Okay, I wrote my whole dissertation. I did a lot of coding for my dissertation. I did a lot of MATLAB code. I had MATLAB code that generated Tickle code that then called on OpenCs to do stuff, and then MATLAB would then come back in and read some more stuff. There's a bunch of finite element analysis. Then I would use it to create all my figures, and then I would even use it. I wrote my dissertation in a program called LaTeX, which is like kind of a programming language. And then I used MATLAB to generate LaTeX code to include. You're gonna love it. You're gonna love it, or you won't, right? I'm teaching a class next semester, civil engineering computations, where we learn how to use MATLAB. For those of you interested in that, I think, I don't doubt you can take everything. Mechanical engineers you have your own stuff. You guys actually lean on MATLAB a little bit more than civils do, but think about it if you're interested. How many are in civil? Who else civils? All the smart ones. All the good, yeah, the smart ones. All right, good. Well, so then you have me in Structures 1 next semester. Yeah, hell yeah, it'll be a good time. It's not until 2 o'clock in the afternoon, so I can ski in the morning. So maybe you should ski in the morning. Okay, so this is right. I just set up what omega 1 and omega 2 are. Right. I set up my matrices. Right. I set up my matrices. I set this, what it actually is, and I take the two and then I add them together. That's where I add the two together. I defined what my position vectors were, right? And then I just do that. VA is cross of omega crossed with RA is seen from O. VP is then just that VA plus the cross of omega P, Q, and RP is seen from A, right? So that's all I'm typing over here. And then alpha P is seen from Q. I just cross those two things together. AA just is crossing those things. And then AP, that's that last little step that we did. You just type it out like that, and then Boom, right? Goes through and gives you the answers, right? Matches our answers that we had before. So if you're interested in doing these, especially some of these big ones, mess around with MATLAB a little bit, right?
If we turn in MATLAB code for our homework.
Yeah, go for it. If you want to do it, right? But again, keep in mind, you can't use MATLAB on an exam. That's the one problem is then you're losing practice and stuff. But sometimes you might be okay with it because some of these big, really long problems, right? So you learn how to do them on your calculator wouldn't be a bad idea either. Okay, let's do this guy. Right? And they all, like I said, most of these problems out of the book fall into these categories where you have a thing that's rotating about another thing that's rotating. Here's another example, right? I've got this wheel that's the end of this rod, right? And that wheel's going to be rotating about the end of the rod, but oh, by the way, the rod is also rotating, right? So just off the bat, the secondary would be the rod, right? Or B, I think is what they're calling it. B. It would be the bar or the rod that's sticking out. That's the secondary reference frame because it's the thing that's being rotated about the other thing that's rotated, right? The body that we're going to talk about is going to be A, right? A is that disc out on the end that's rotating about the end of the rod, okay? So we've identified that. I guess I could write that down. Body is disc A, right? Secondary is bar B. Right? One of the first things that you should just kind of take a step to do that. Okay. Okay. Right, so all they tell us, they only give us one omega here. I know you guys hate doing this symbolic, but this one's going to be symbolic. They don't tell us what omega naught is, right? I don't think they tell us what omega naught is, but that's the only thing that we're given, right? And so you've got to just take a second to think about this. Omega's going to rotate around like that. So this bar is going to start rotating that direction. And so then this wheel is going to, as a result, going to start rotating that direction, right? It's going this way, and then the wheel is going to start rotating around that direction, right? Everybody see that, right? If a wheel is rolling without slip, right, then that thing's going to have to rotate. Instead of sitting on the ground right there, and it's going to start rotating. Okay, how do you think you would do this problem? Huh? Carefully, very carefully. Be careful with your cross products and stuff like that. What do you think? Huh? Take a step. Yep.
You could do B to A, or you could do the bottom to A.
Yeah, you're both of those things, right? And we have to do both of them, right? So there's two velocities that we know on this whole thing, right? I know the velocity at this point right here, or here, either one, right? They don't give us this dimension. They don't give us this step up or whatever. Yeah, they give you R. But it doesn't matter. This doesn't move either, right? It doesn't move down here. It doesn't move right here. I know the velocity right there is 0, right? And I can take a step out to this point right here, right in the center right here. But also, I know that this point right here is 0. Okay, that's not moving either because that's the bottom of a rolling wheel. And so I can take a step from here to here too. And what about those velocities? They have to be the same, right? The velocity right here coming from here has to be the same as the velocity here coming from here, right? And so they have to be the same. So that's what we're going to do. We're going to say, I'm going to call this point in the middle G. I'm going to call that point in the middle G, right? And so I'm going to go to G from,
We have another G
do we?
above on the Z-axis.
Oh, you know what it is? You know what that is? The thing moved. None of these things mean anything. My image moved. So he used to point at G. Okay, so erase your G and put your G right there. Okay, let's call this point right here C, right? And I'm gonna call this point right here D. Right, so I'm gonna go to G from C and I'm gonna go to G from D, right? So let's do that. Okay, VG, right? Just use their equation. VG is equal to VC plus omega of B. Oh, I'm gonna call it bar so we don't confuse it with the omega beta that we had before. Omega the bar crossed with R, G is seen from C. Hey, what are we after anyway? What did the thing ask for? the angular velocity of the disk and the angular acceleration of the disk and the velocity and acceleration at point P. Right? That guy right there, point P. Okay? Right? VC is 0. This is equal to omega naught in the K direction. That's omega of the bar. Right? It's going like this, right? Thumbs pointed up in the Z direction. It's omega naught in the K direction. And I cross that with 2R in the J direction, right? And that is this vector right here. C to there, that distance right there is 2R, and it's in the Y direction, which is the J direction. 2R in the J direction. This ends up being equal to negative 2R omega naught in the I direction. Okay? If that makes sense. This thing's saying that this is going negative I direction, right? Negative R omega in the I direction, right? And so again, could you get this? Like, could your intuition tell you that it's going to be R omega in that direction? Yeah, right? I think it would, right? Like, this thing's rotating around omega naught, and I'm looking at point G, and that's just, think of it as a plane. If I'm looking down at it from above, it's just going to be R times omega in the negative I direction. Sure, right? Sure, your intuition could get that. Some of these later ones, it can't. Right? But again, I would just, if you stick to this plan, right, it doesn't matter if you see it or not. This math, let the math work out that stuff and then check it later, okay? So VG is negative 2R omega naught, okay? Now I'm going to go to VG from point D. VG is equal to VD plus omega disk crossed with R G is seen from D. Okay. Now I'm out. So I get a little complication here because now I'm out on that disk, and that disk is rotating about a thing that's rotating. So I have to come up with that. We're in the body, right? When we're on the body making this step, right? On the body making that step, I can't just do this one omega. I have to do this omega, and I have to add on to it this omega. I have both of those omegas floating around, okay? So this is where it gets, like I said, it gets a little more complicated because there's a lot more going on out here. This is gonna be omega of the disk, or the body, right? Equal omega of beta is equal to omega of the secondary plus omega of the body is seen from the secondary, which is going to be equal to omega of the secondary is omega naught in the K. And they add on to it omega A as seen from B. That's omega of the, well, let's keep with our disk and bar. Disk as seen from the bar. Right? What I do know, I don't know its magnitude. That's the value I need to kind of get. But I do know which direction that's at. Like, so I'm looking to see what this term is right here is what is this disk doing relative to that bar, right? You know, it's going to be rotating around which axis? J, yep, the y-axis, right? It's rotating around the y-axis. Positive or negative? It's going to be rotating in the negative, but we just put it in as positive. You always put it as positive, and the answer will turn out negative. So you just say it's going to be omega AB, the magnitude of omega disk is seen from the bar in the J direction. So you just put that in as this. Ooh. Right? And just put it in as a positive value, and it should turn out to be negative eventually. Right? But again, let the math do that. Okay, so then let's do that. Keep going with this. Right? VD right here, that's 0, right? Because that's the base right here. That guy isn't moving. Right? So that's going to be omega the disk is going to be omega, oh, black. It's going to be omega naught in the K direction plus omega disk as seen from the bar in the J direction that quantity crossed with our G seen from D, which is going to be R in the K direction, right? That's this guy. I'm down at D. I take a step up to the center, G right here, and that is the radius R in the K direction, right? In the Z direction. Okay? So you carry that cross product out, and what you get here is this will be R omega, I keep calling it disk. In from the bar in the I direction. Right. And this is a K crossed with the K, so those guys go away. And so you just have that, right? And that's in the I direction, right? And so now I have VG coming from both directions. Yeah.
Where's that negative coming from? You said from positive J?
Wait, where?
Omega disk over bar J. You said you're going to make it a positive, but it's going to result in...
Oh, yeah, we just, you put this in as being as a positive value. See, I added it, and then when I get this, when I solve for omega disk as seen from the bar, it should be a negative. It should turn out to be negative. It should be opposite of the other one. Okay? So now I've come to VG, right? I went to VG from point C, and I got the value, that's this, and I've gone to G from the bottom, come to this. And so these two things are equal to each other, right? They have to be equal to each other because they're attached to each other, right? So that's what you say. VG is equal to VG, right? And what we get there is negative 2R omega naught in the I. Thank goodness they're both going in the same direction, right? R times omega disk as seen from the bar in the I direction, right? There's our relationship, right? These guys, right? Obviously they're both in the I direction. R's go away. And our relationship is omega disk as seen from the bar ends up being equal to negative 2 omega naught. Okay. That's just part of it, right? All of that was just to come up with a relationship between how the bar rotates and how the disk rotates, right? And again, would your intuition tell you that? Probably, right? Probably, right? Because one's coming around, but again, right? You don't really have intuition yet. Nate Dog, did you come in late? Yeah, it's all right. It's all right. It's okay. It's okay for you to come in late. It's just if it's this size, but just coming in tardy today. Yeah. So that, right, that one's coming around, it's got a radius of 2R, and the other one has half the radius of just R. So, right, that should be rotating around twice as fast, right? That guy's coming around, so every time it makes one swoop around, the other one will go around twice as much, right? And then it's a negative, like I said, it should turn out, omega disk and C to the bar should turn out to be negative because, right, omega Z is going this way, and then the other guy's going to be rotating this direction, which is the way we have it drawn in the negative J direction, right? So that'll be omega naught will be positive, and the other one will turn out negative, right? Pretty cool. Now that's only a very, 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 very small part. Very small part, right? We got to keep going, right? We just came up with a relationship, so we figured out how much this omega was rotating, right? And we still have lots to go, right? So the next one is we got to figure out what the omega of the disk is. That one I got. That one we are done with. Right? Part A is omega of the disk, right, is equal to omega naught in the K minus 2 omega naught in the J. Right? So you add in both the components, right? This is omega of the secondary plus omega of the disk as seen from the bar. All right. So that's all that one is, right? So there's that. Let me do that guy. Bless you. All right, I'm gonna call this omega A. I get tired of writing disk every time. Omega A. All right, that's our disk is A. I think we'll use that a lot later, and I just want to write omega A instead of writing up disk every time. Okay, that's part A. Part B now said. Part B is what is the angular acceleration of the disk? Okay, that we have enough information for. B. Alpha of A. Right now we're switching over to calling the disk A is equal to alpha of the secondary plus alpha of the body as seen from the secondary plus omega of the secondary crossed with omega of the body as seen from the secondary. Okay, so this thing came out right at the very beginning. It said our omegas were constant. If our omega naught is constant, then omega of the disk as seen from the bar is also constant. So then this guy right here is 0. This guy right here is 0. But we're still going to get angular acceleration because we have a thing that's rotating, that we're changing the direction in which it's rotating, right? So we have that last little component there. So this is going to be omega of the secondary is omega naught in the K. That's omega of the secondary. And I'm going to cross that with omega body as seen from the secondary, which is negative 2 omega naught in the J direction. Okay, that's just this right here. Well, let me just, this is omega disk as seen from the bar. Is what that is. Right? It's not the whole thing. It's not the whole omega that the disk is doing. It's just what the disk is seeing as seen from the bar. So it's just that other component, the negative 2 omega naught in the J. Right? And so you carry that out. And that is 2 omega naught squared in the I. That is one of the other answers that they were after. This is what alpha of the disk is. Right? And again, it's weird, right? So this thing's rotating around this axis, is rotating around the Z, and it's rotating around the Y, but we pick up an acceleration about the X, right? The X axis. Right? And so actually what it would be doing, right, is it would rotate that, it would want to start twisting down like that, so you would have to apply a moment up to keep it from doing, or the ground would be pushing up more. It would want to rotate down so the ground would be pushing up more. And it's going to come in, that's what we're going to work out later, is like how big of a force is going to need to come up here. You want me to get that for you? You got it?
Yeah, I got it.
Okay. It's going to come up like that, or what kind of moment does that have to resist over there, right? And so there is a weird, again, that's what you felt when you rotated it around. You felt this off-axis thing. What you were feeling was this, right? Was that guy right there. Okay, so that's B. We got B done, right? C now, velocity at point P. I think we have all the components that we need now. C, we want VP. Okay, so that, I just take a step. I know what VG is already, right? I take a step from G out to P, right? Because we found VG a couple different ways. We'll say that VP is equal to VG plus omega of the body, crossed with RP is seen from A. Because I'm out on the thing that's rotating about the thing that's rotating, so I need that total omega, right? So VG we determined already, right? We determined VG. Oh, I did it even smarter than that. It would go from G, but the other place what I did last time is I went from D down here, because that's just 0, right? That one's 0. I could take a step from D up to P as well. But we also have G, so I'll go from G. So versatile I am. It is. Yep. That wasn't done yet. I was just gonna say. Okay, so let me just keep going. VG, we can use either VG that we want. Now I'm gonna go from D. I'm gonna go from D. You could go from there, but I like it's just cleaner going from D. So I'm gonna say or VP is equal to VD plus omega of the body crossed with RP seen from G. Again, our P is seen from D. Yeah, I wasn't done yet. I was just gonna say that. What did I do? Those wrong. VD 0. Right now, the only omega that if you do it this way, you just gotta be careful of your omegas that you're using. This guy right here, though, it's a little bit cleaner. Like I said, you only have one omega the body now. So now this is what I called omega A. Right, we called this omega A. That's just going to be the value that we determined up above. That's omega naught in the K direction. Crossed with our P is seen from D, which is going to be 2R in the Z direction. Oh, wait, I'm not done. I got to keep going. Omega disk, omega naught in the K minus 2 omega naught in the J. And I cross that with 2R in the K. Right. And if you calculate that out, this is negative 4R omega naught in the I direction. Okay? If you carry out that cross product, that's what you should get. So that's what VP is doing. Again, just make sure that makes sense. That VP, if this is rotating around that axis and this ends up rotating around that direction, you're getting, that guy going that direction. I buy that. I buy that. I buy that. Okay? Okay? That's VP. Last step is to acceleration to point P. D. Uh-oh. D, what is AP? Okay, so I got to kick, we got a lot of stuff here. I got to go to P. Right now, I do not know what AG is. So I actually have to go, I had to go one extra step this time. I got to go from C to G, and then from G up to P. Okay, so AP is equal, AP is equal to AC plus alpha of the bar. I'm only on the bar. Crossed with RG is seen from C plus omega bar crossed with omega bar crossed with RG is seen from C. Okay. AC, like I said, that point is not moving. Alpha of the bar, it's a constant omega. That guy is 0. And so you're just left with this double cross product at the end here. This is just going to be omega of the bar is just omega naught in the K. And I'm going to cross that with omega naught in the K. Cross that with our G is seen from C, which is G is seen from C, which is 2R in the I direction, 2R in the J direction, 2R in the J direction.
Are we doing AP or AG?
This is a, oh yeah, fuck. I wasn't done yet, Mark. You always corrected me too soon.
I was asking.
No, you were correcting me. You're in trouble. You should. Don't ever correct me. I'm always right. I was just gonna say, what did I do wrong in all of this shit? It's good. Thank you for pointing this shit out, because it's hard enough already, and you're like, what the fuck's happening? And then I keep making mistakes. Say again. What now? Okay, I wasn't listening again. All right, this time for reals. This time for reals. I got you.
How do you get in the I direction for BP? Do you cross KJ and then cross with K?
K's go away and J and K goes with the I.
K's go away.
K's going. K cross with K is nothing. Right?
Because wouldn't you do like K times with J, cross with J?
I go with K cross with the K, that nothing, and then I go to J cross with K gives me the I. Oh. I don't know what that X is in there.
Okay, got it.
That's
Well, that was multiplication, and then you said you forgot something, so you had to add on the 2.
Oh yeah,
Omega.
that wasn't done yet, sir. I was just gonna say, what's wrong with that equation? And there's no X there. That's sorry, my bad. It's just minus. There's no cross happening there. You're right. You said I did. I started to cross, and I said I forgot a component, and then I went in and I added the extra component, and then I forgot that. God, my apologies. If you guys make it through this, it'll be a miracle. Who fucking wants to do this stuff? This stuff is crazy shit, right? Yes.
The final exam be extra credit.
No. This is easy. Like I said, you're gonna make mistakes, and then
But you're gonna grade nicely.
I grade nicely. Absolutely. You set it up right, and it's something little like that. I don't hit you too bad. You're aware of that. I'm not out to get you. Right? So AG, if you carry out this, we get this ends up being equal to -2. -2 R omega naught squared in the J. In the J. That is in the J. So acceleration, right? What we're after here is this acceleration right here at point G, right? And it is going to be accelerating back towards the middle, right? In the J direction with R omega squared, right? It's the centripetal acceleration, right? Again, could you look at this and apply some intuition? Say, well, that's just rotating around in a plane, so the only acceleration is going to be the centripetal acceleration back towards the middle. Sure, right? But would you recognize that? I don't know. I don't know if I'd recognize it, right? And so sticking with this, I like to do it where I calculate it first and I just go back and say, well, does that make sense? Yeah, that makes sense. That's the centripetal acceleration. It's the R omega squared term, right? That's going back towards the middle, okay? Cool, maybe we're out of time. So next time we'll take a step. The last step is to take a step we have all the components from here to here. It's just now, oh man, there's a lot of stuff going on, right? Yeah. It's the double cross, right? Nope, because you gotta carry the one out the first. Yeah. Orders of operation. Inside the parentheses, that'll give me an I, and there'll be a K with an I. Yeah, that's where you get the jet. Yeah, you gotta carry it. I don't think they put the parentheses on there in the book, and I always just put them there. Just make sure you do that stuff in the middle first. Yeah.
I wrote 8 and then I realized, wait, am I vector or I wrote
I got a question.
Yeah.
So at the very beginning, like at the very first line,